So there's a reference in the original student notes from the first module, I think. There are 700 different slides. So when you see a reference that's in the 200s, we don't have the 700 slides, and then you're trying to dig out in the 200s. What we have in here is the publisher slides that have to do with DOCSIS and cable modems and so on. And what we'll do is provide that in Blackboard if it's not already in here. I just want to make sure that there's something in here, selected slides by the author, right? So if you take a look at the selected slides by the author, this is the same series of slides that you're about to see here. And it's a review of much of the content. What we want to do is focus on cable modem and DOCSIS. If we find that that term is not in here, then we're going to post all of the slides as well, so that you can find the reference here to slide 209 to 210 for DOCSIS. In fact, I'm going to go ahead and see if I can ferret that out right now. Here it is. Slide 201. That's multiplexing. 209 to 210, okay? DOCSIS is a digital transmission standard on layer 2. And it's used with coax cables. Coax cables are single conductor. There's a single wire in the center of it. It's typically copper. Sometimes it's aluminum, but typically copper. And it's insulated. Around the insulation is shielding. Around that is more protection, more outer coating, and a protective layer that's usually black. Coax cables used to be used to connect your TV to the cable TV provider, and cable TV providers became interested in providing internet service after the Telecommunications Act in the 1980s went live. So essentially, as the internet was coming into its own, the federal government realized that telephone companies really had a strong grip on everybody's access, and they wanted to induce some fair competition. The Telecommunications Act, I think, of 1986. So that was quite a while ago, but what's happened since then is that there's been a very rabid, not rapid, well, also rapid, but rabid pace of dog eat dog, and a lot of internet service providers have come and gone and been consumed by other internet service providers. Perhaps the most familiar example of this mode of internet service, a very popular service provider named Time Warner became a giant in the industry. And then, of course, there was more corporate purchases, and then things have changed since then as well. So what you're going to find is that our local provider, Via, will sometimes provide internet through this same digital coax copper. One thing to understand is that the other types of internet service, broadband internet service, don't tend to share the neighborhood bandwidth. But if you're the first in your neighborhood to have coax internet service from your internet service provider, then you're going to find out it's very fast. And as word gets out, more and more people subscribe. And as more and more people subscribe, what they end up doing is sharing the capacity of what's called, there's a junction, like a switching facility nearby. When you're dealing with phone lines, the broadband service is called DSL. It uses a plain old telephone line, and it provides broadband internet service. AT&T would be a good example of a telephone service provider that had plain old telephone lines and then converted them to a digital subscriber line concept. And essentially there's this concept called a DSLAM, a DSL access multiplexer. It's back in the day when we had phones, just plain old phones, they had a green box near housing subdivisions. And if you drove around, you could see a green box near a housing subdivision. And it was called a SLIC, subscriber line interface circuit. And essentially what was happening is that if you had 100 houses in a subdivision in a city, 20 main trunks or main circuits would feed the SLIC, the box. And then from the box, there would be other lines out to each of the 100 houses. Now, what do you suppose happens when you have 20 main telephone lines or trunks, and then something bad happens, like an earthquake, a hurricane, a catastrophic event, a big news event, or Mother's Day? Let's just talk about Mother's Day. What do you think happens when 100 homes pick up the phone to call mom on Mother's Day, and the entire subdivision in a city is only fed by 20 trunks? What is it you hear?
You're gonna have a lot of traffic going in between those broadband networks.
Yes, you're going to have, now I'm talking about old school telephone, but yes, you're going to have the same phenomenon with the broadband. So in modern terms, if we fast forward to today, people are using IP telephones, right? We're using digital telephones. And oftentimes our cell phones can ride on top of Wi-Fi signals that our broadband service provider is bringing into the home. And yes, it's a log jam. It's a 10-lane interstate highway leading to a 3-lane tunnel. Everything backs up and slows down. Now, every so many years, every 2 to 4 years, sometimes 3 to 5 years, depending on the transmission model and the industry leaders in that field, you get new standards. So for DSL, they had an ADSL, which was an improvement. Now they have ADSL 2+, or VDSL. And what happens is that every time your contract term is up, you can say, well, I'm really, it's not fast like it used to be. I'm getting the other carrier provider's service. And this has spurred a lot of competition between service providers, especially those that differ in terms of delivery, the physical layer and layer 2. Now, DOCSIS, so if you're talking about phone line, just plain phone lines, old school phone line, the broadband that rides on top of that is called DSL, digital subscriber line, right? DSL. And digital over cable service interface specification is what DOCSIS stands for, okay? That's literally what DOCSIS stands for. And the latest versions of that deliver 100 megs, 200 megs or higher, DOCSIS 3, right? I've seen cases in the last 2 years in the Carolinas, in the metro areas in the Carolinas, you could get a gigabit of bandwidth space over cable with the latest DOCSIS, right? And that's that's wicked fast. But now AT&T has come back with fiber service. So AT&T provides 2.5 gigabits per second to a house for about $120 a month. And they literally put a yes made of glass fiber optic cable right into your home under the ground to deliver 2.5 gigs of service. So they're always in competition with each other. The thing to understand though is that the more neighbors in the neighborhood that hop on the lines, you get a bottleneck eventually, depending on the delivery mode and how well that stuff works. So that's one aspect of broadband service that's important to understand, is that there's this SLIC or DSLAM where all of these lines come together, and then there's only so much data going back out to the internet. When you have too many subscribers for the amount of data that goes back out to the internet, this is called oversubscription. And it is the internet service industry's dirty little secret. They will advertise if they start losing customers. Oh, you can get 500 megs a second, and but it's only $200 a month, and they may or may not have all of the hooks behind it to actually deliver on demand, even though they're taking orders, because once they get a certain number of orders, then the company says, okay, now we have enough customers in the area, we can run that fiber. So it's quite a process to try to get fiber into an area. And at my former campus, we were the reason that Bamberg County, South Carolina finally received fiber optic cable for the internet, because we placed an order from Carolina with a company in Chicago, Illinois, who under contract made the local telephone company do it. The local telephone company said, yeah, we're not going to do it. So we worked around. Now, why am I sharing this with you? I want you to understand that sometimes there are interesting and creative ways you can leverage competition with internet service providers to get better service, or to get more cost-effective service. Maybe they lower the cost of your monthly service when your contract renews. We've already talked about Starlink, and Starlink has the potential to shake things up, where metropolitan grade high speed, which is now measured in gigabits. I mean, that's kind of mind-blowing. To put this into perspective, I think the University of the Virgin Islands at each campus has 1 or 2 single gigabit lines out to the internet, and that's it. And they're upgrading all the time. And in the last season, they may have upgraded those back-end connections to the internet. In fact, I think there was a plan to do that. But that is one thing that creates a problem. I'm going to take a short segue to jump out to slide 209 and slide 210. And so 209, whoops, 209. So in its original incarnation, the maximum downstream data rate was 52 megabits per second. Well, things have changed. The copyright on this slide is 2014. And in the last 9 years, they're clocking very much more than that. We talked about multiplexing, and DOCSIS uses multiplexing to get more subscribers on the same line, okay? So each subscriber receives one end of the bandwidth, and that means if you have 10 subscribers on your line, then you get 1/10 of the bandwidth. If you have 100 subscribers on the line, you get 1/100th, because n equals 100. Does everybody understand what's going on here?
Yes, n equals 100.
Yes. just wanted you to be read into this, all of this, because what's the point of learning about digital networking at a university level if you can't come home and work some practical judo with your service providers over the terminology? They tend to be more responsive with calls for service enhancements or improvements, especially when you're troubleshooting. If you call and they say, well, my cable is slow, well, my stuff isn't, you know, whatever. The first thing you want to do is make sure that because this is electrical, what component should you check to make sure is healthy and exists with your connected equipment? The single word starts with the letter G. What do you have to?
Grounding.
Yes, yes, yes. Thank you. Thank you so much. Grounding. Yes. When you call them, you're going to say, I have already assessed my grounds. I know I have solid grounds in my house. I know everything is properly connected. I know the interface has no physical deformities. You know, the connector on the end is not loose. So the same thing that happens with an Ethernet connection is that the plug starts to work loose, and sometimes simply re-terminating the plug can solve a huge problem. It's just hard to get the service truck out there to do that kind of thing. You can get the tools, and I can show you how to do it the next time that I am in the classroom physically. There have been some delays with the commuting flights over to St. Thomas. I think that had a lot to do with the ag fair. Everything was booked, and it was impossible to get some flights this last week as intended. So for those of you who are on St. Thomas and we're looking forward to a sit down in the library, and I was going to bring a toolkit and a whole variety of things, and you know, kind of a show and tell session, that's still coming, but we are going to exhale after the ag fair has ended and then get in line for a commuting flight over to St. Thomas. I just thought I'd provide a quick update on that point to those of you that are over on St. Thomas. In any case, I can bring all the tools to show you how to put a new end on the cable, modem cable, or a new end, a new plug on an Ethernet cord. And those are things you want to explain to your tech support. You say, oh, I have a cable tester, and you know, the cable test's good, and we've re-terminated. The term re-terminated, everybody, repite usted por favor, re-terminated. Go ahead, unmute your microphone. Let's see who's actually with us.
Re-terminated.
Re-terminated, like
Re-terminated.
yes, you can sound like Arnold Schwarzenegger. Re-terminated, right? Re-terminated. You tell your service provider, I have re-terminated the cable ends and tested them, and everything is smooth, fast, and hot. And I have completed coursework in digital networking at the university, and part of that is hands-on and physical, and I can save you some time with your checklist. And they'll say, well, we still got to go through the checklist. And you say, oh, okay, I know it's required. But it's a much quicker checklist, and you knock out the each of those tasks in the checklist a lot faster. Remember, you're always resolving the physical and the grounding first, right? Now, other access technologies, we call them hybrid systems. So optical up to a point, and then copper with coax out to the house. So that's kind of like DSL, where you have this DSLAM, you have optical to a box in the neighborhood, but then from there, it's coax cable, traditional coax cable, like old school coax cable to your cable service with all the cable channels, right? And it's there to deliver the last segment. It's called the last mile. So the piece of wire or fiber that connects your home out to the service provider switch box. That's called the last mile. And that's usually the bottleneck in most communities, okay? It is true that St. Croix connects North America and South America on the internet backbone globally, and 4 times the amount of data that is consumed every day in Silicon Valley proper. All of the big giants there, Apple, HP, IBM, Microsoft, Amazon, right? Google, all the big ones, all of those companies combined in Silicon Valley, 4 times that amount flows under our feet in St. Croix. From one end of the island to the other, out the other side, on over to North America or South America. The sad part is you have to have some way of tapping that and getting it into the local communities. So we have a huge amount of potential to have very fast internet if we could work with our telecommunications providers, our internet service providers, to tap into some of that access. That's another topic for another day. Fiber to the curb. So when you get fiber to the curb, that means that you're close, but you're not in the building, okay? When you get fiber to the home, that means you're connected, your home is connected to fiber. Inside, it's wireless or Ethernet, right? So curb, building, premises, home, pretty much the same for most of those. But curb is a problem because you got to jump from the curb into the home, and there's usually a secondary cable. So how much capacity is needed at each point downstream? What the author is getting at is oversubscription, right? If you have a lot of traffic downstream and the connection on the back end is lighter weight, you're going to have some bottlenecks and slowness. And internet service providers don't always tell you, oh, well, that's an older trunk in the neighborhood, right? So these are things you can talk about. WiMAX is a way of delivering internet by radio waves. You have a little radio dish on the roof. Does that sound familiar to anyone in the audience today? Just saying.
WiMAX? No, 4G, you mean?
Yeah, not 4G, WiMAX.
Oh no, WiMAX? You know what?
It's a way of getting the internet
Never used it.
by using a little radio dish on the top of your house. Does that sound
Really?
familiar to anybody?
Oh, like Direct TV or Dish?
Like DirecTV or Dish, but does anybody have broadband VI and you got a little antenna on your roof?
Oh no, no I
Oh
don't
yeah, I
Nah,
do. Yeah,
I
yeah,
don't
I
have
do.
broadband VI. No.
Yeah.
Is that what it's called?
Well, there's a service like it that broadband VI uses, and WiMAX is another flavor of the same concept. You have little antennas, little dishes, and they all point to a big antenna on a mountaintop or on a radio tower, right? And that's what WiMAX does. So it's a way of delivering subscriptions to users without any cable at all. And they do this out in the open where it's not cost effective to run cable for just a couple houses, right? So the other kind
Does
of
it do poorly in the rain though?
go ahead. Is that a question?
Doesn't it do poorly in the rain?
Yes. The short answer is it's not completely impervious to rain.
Yeah, because my internet always used to cut out where it used to rain heavily.
Yes, that's often a nuisance issue. And there are newer technologies that are more resilient to rain, like optical wireless with lasers. And we've talked about that before. Okay, so slide 211. There are other data options, cellular and dedicated circuits, I'm sorry, not circuses. Whew. And once again, this is the market space for services like broadband VI. And now Starlink. I want to talk a bit about leased point-to-point circuits. This is a dedicated circuit It's usually a copper circuit, and it connects, it can be fiber. It'll connect to the backbone of the internet. And there's typically the same kind of bandwidth upstream and downstream. This is what companies use when they are hosting their own email servers and their own web servers at the company headquarters, and the general public is connecting to those email and web servers. So there's an amount of upstream traffic that needs to be supported. Broadband data on a network tends to be asynchronous, meaning more downstream download performance and less upstream or upload performance. But a point-to-point circuit, a T1 or a T3, they also call them OC3s, OC45s. These are a megabit a second, 4.5 megs a second, and then all the way up to 45 megabits per second. So, and then if you get into fiber, you get into much larger bandwidth. The important point to understand is that a point-to-point circuit is leased from the local exchange carrier, or LEC, local exchange carrier, or LEC. Put another way, there's a telephone company and there's an internet service provider, and they set up a circuit with the help of the telecommunications or telephone company, and it's a point-to-point circuit, and they lease that circuit to carry their data across it. And of course, they pass the cost on to you. These kinds of circuits tend to be very costly, but there are times where it's the best option because of the type of data you want to serve up to the general public. Any questions about leased lines? So yes, cellular companies are getting in on this, right?
Wait, are lease lines? So are they similar to when, like physically, is this similar to when someone leases an IP address? Is that like the same? So you're paying for the line to use, and when you give up that lease, now the line goes to somebody else?
Correct.
Oh, okay.
It's a physical point-to-point connection so that you can stream high-speed data. And somebody has to maintain the line, and usually the telephone company or an internet service provider has to maintain that physical wire or fiber. So now we want to talk about optical. When we talk about fiber optics, by the way, did that answer your question?
Oh, yeah, definitely.
Okay, all right. We said that fiber was kind of like having the Alaskan pipeline in digital terms at your fingertips. A single fiber can carry 1,000 times more just by changing the color of light transceiver that's being used on the fiber optic. So if you change the color from orange to ultraviolet, you can carry 1 billion times as much data with the right algorithms, of course. Now I'm oversimplifying a bit, but that's kind of how it works. Now, if you have a large fiber network, it's called SONET, synchronous optical networking, and that's a ring topology with opposing, or you have clockwise and counterclockwise traffic inside each other with concentric rings. Concentric means one ring inside another larger outer ring, okay? And one of those circuits is going in this direction, the other circuits is going in that direction. And that, again, that's an oversimplification, but basically you have redundancy with that fiber network. The largest lines are called OCs, optical circuits, and an OC 192 can carry 10 gigabits of data. So that's enough to support 150,000 simultaneous phone calls. The fiber under St. Croix's, under Crucian feet, is many times that large, okay? Many times that large. So when our circuits are busy, you have to wonder, okay, what's my provider doing here, right? Well, if they sell data service for more and they serve more customers and they stretch the capacity of their lines, then they can make more money. It's all about making money. One of the things that we want to share is this hybrid kind of trend on the physical and data link layer. If you take fiber and you take Ethernet in a metropolitan area, in a campus, in a physical locale that's the size of a college campus, a university campus, or a city, this is referred to as metro Ethernet. And those are very fast business grade circuits, much like a dedicated point-to-point circuit. Metro Ethernet is replacing the point-to-point circuit, and so are OCs, optical circuits, right? OCs are optical circuits. So whenever you see the word OC, we're looking at a fiber of glass that transmits laser pulses, very high-speed laser pulses. And of course, this is going to be the backbone of what allows for your 5G cellular service. So when you talk about cellular, one of the things that you have to understand is that the radio waves occupy different points of the spectrum, electromagnetic spectrum, and cellular is no exception. So cellular is a different frequency and a different delivery algorithm than Wi-Fi. Okay. The 802 standard, one of the things you need to do before you take your assessment for the module 2 assessment, you want to take a look at the 802 dot standards. Now, when I say 802 dot standards, I mean 802.3 is Ethernet cable. Old-timey all right, so coax is another standard. Bluetooth, when you form a proximity wireless with Bluetooth, that's called proximity wireless. So Bluetooth is another flavor of 2.4 gigahertz wireless, and that standard is IEEE 802.15. WiMAX is 802.16. 4G LTE mobile broadband. Here you go. Everybody's favorite, 802.20, right? What's Wi-Fi? 802.11. 802.11. I'm going to expect you to know the big ones, okay? Now, cable broadband internet formerly used 802.7, but now it uses 802.14. The higher speed DOCSIS uses 802.14. How can you remember that? Old school cable modem used .7. New and improved cable modem high speed uses 14. Well, 7 is a multiple of 14. You get twice the bandwidth, okay? Just deep processing that with you, maybe that'll help. There are other standards of wireless networking. If you have smart power meters, smart water meters, sometimes they use a radio signal that's similar to Wi-Fi, but it's not Wi-Fi. It's called Zigbee. Zigbee. And it connects systems that are multi-homed. So if you have a neighborhood of homes and they all have power meters and all the power meters are connected together, it may not be cellular, it may not be Wi-Fi, it may be Zigbee. Okay. But usually in that case, there's a nearby box that converts Zigbee to another signal to get the data back to the power company, right? Now we talked about 568A and 568B. These are considered obsolete, right? But as you get to Cat 6 and Cat 7 and Cat 8 standards for the cable itself, now you're dealing with 568C2, covers copper twisted pair cable. C.3 covers fiber optic cable. So these are important documents to just have a quick look at. And this is literally the TIA standard. This is the nationals. ANSI means US federal, so it's American standard, right? And it's good to basically just review this in brief. We don't expect you to know all of this, but there's useful information in here. So I like the pretty pictures. So sometimes it shows you all these different standards and how they connect. And at some point we should see some kind of diagrams on wiring, right? So these are the 568A protocol. Those are your colors. Everybody remembers white, green, green, white, white, blue, blue, white. Does that ring a bell? Yes, please tell me.
Yeah, you were saying for the way the Ethernet, like the hard plastic part, like how that's how they should line up.
Yes, exactly. Thank you. So here you see Cat 3. There's a Cat 5 that was replaced by 5E. There was a Cat 6. Now there's a Cat 6A. 6A is easier to work with in terms of the thickness of the cable in your hands and such. And then, yeah, you see all the information and some really interesting physics stuff. If you want to get into the complex math for the algorithms, this is all in here, right? It's all built into your study guide. So just wanted to point that out to you. Any questions? All right, so I'm going to try to blitz the last few concepts so we can end close to time. Broadcast. We were saying that broadcast is true for wired Ethernet connections. It's also true for wireless. And when everybody's talking at once, there are lots of collisions. You have to have a way of managing the data transmission. And none of this would happen, right, if you didn't have some sense of when packets were colliding so that you could repeat the transmission or you could broadcast that specific packet again, right? So if you look at, where's our, oh, there it is. I was looking for for a snake, it would have bit me on the nose. 244. So carrier sense multi-access with collision detection, that's CSMA-CD. And then there's carrier sense multi-access with collision avoidance. The CD is what's used for Ethernet. The CA is what's used for Wi-Fi. Let's say that again. The CD is used for Ethernet cable. The CA is used for Wi-Fi. We would rather avoid collisions in a wireless environment. You can jam radio signals just by putting out the same radio frequency and just blasting it, and it steps on the other radio signal. So that's one thing that creates all kinds of problems, right? Now, normally on a switch, when we say on a switch, Ethernet, I want to qualify that. On a switch, Ethernet receives a broadcasted frame only when the MAC addresses match. But you do have this thing called promiscuous mode, where you tell the port on the switch or the port interface on your PC to listen to everything. This is a very important setting for hackers and network security professionals. So what you're doing when you're using Wireshark, it's a network sniffer. It captures all the packets from all the machines, all the connected devices, in order to perform analysis of the traffic to help troubleshoot. So it's a useful tool, but it's also used by hackers. You have to dedicate an Ethernet port on the switch to mirror all the other traffic from all the other ports. This is often called a span port. It's a single port where all of the traffic from all the other ports is basically is mirrored. So the one port spans the traffic on all the other ports, right? Somewhere in here, so there's good detail in here about Xerox and the early stages of Ethernet. You may find span in here. There is, we talked about dual homed, right? Now, if you connect two network interfaces and they loop, it can crash the network. Yeah, let's hold that thought. We'll pick up that trail on Friday. The important thing to understand is that network sniffers, you have to set up the special port that allows you to capture all that port spans the traffic, or it mirrors the traffic from all the other ports on the switch, right? So Cat6 can now support 10 gigabit wire speeds, and this is possible in the home. You'll see lots of YouTube videos on, hey, set up your own 10 gig wire speed in your own home. We need to take some time to talk about ad hoc wireless. This is cool and it's convenient, but it's dangerous as hell. Okay. Ad hoc wireless is often referred to as peer-to-peer wireless. Okay. So what am I talking about? Did you know that you can connect your laptop to a wireless signal in an airport? And then if you have a second adapter, like a USB wireless adapter, you can name that adapter free Wi-Fi. And then you start broadcasting. Hey, you set it up as a peer-to-peer or ad hoc wireless. What do you think other travelers in the vicinity around you see? Free Wi-Fi. What do? They connect to it because the name of the host is called free wireless. And they think, oh, this is the airport free wireless. They connect to it and they're connecting their internet through there. And what do we say about wireless? You can see everything anybody clicks in, right? Anything anybody types, anything anybody does on the web, you can see it over the wireless connection. If they're connecting to you and then on the back end, you're connecting to the internet, you're sitting in the middle. This is called a man-in-the-middle attack. Now, that's the point we're going to close on today. I don't want to run any longer. We'll pick that up, but I want you to think about that. Also, Bluetooth is supposed to be good for 30 feet, but I also want you to know you can go almost over 100 feet. If you modify a Pringles potato chip can and connect it to your wireless adapter, you can eavesdrop on people's Bluetooth headsets or earbuds so that they're having a phone conversation. You can hear the whole phone conversation using a Pringles. So these are things to consider about network security that we're going to go into greater depth in Module 6, our special topics module. But these are important things to mention while we're in the neighborhood. Can anyone think of any questions or offer any comments based on the material presented before we close the session? Going once. Going twice. Okay. Thank you for joining us today. Please remember to start up your tasks in the assignments and the solution so that those are done by the end of this week along with the rest of our material. So as we get into the weekend, you can log your first attempt to the Module 2 assessment. Take care and goodbye for now.